Hi, welcome back into Stat Students. So today, my last exercise was finding the conditions for a z-test about a proportion, and there were three of them, right? The random, the normality, and the independence rule, right? Independence condition. So today we are doing calculating the test statistics in a z-test for a proportion. Okay, so to start, we need to write down what the z statistics formula is. Okay, so the z statistics, okay, oh, well, perhaps I need to do a better job with my spelling. Z statistics, okay, that works. Okay, and that is usually right. So z statistics, in a way, you can look at it as how many standard deviation is it away from the mean. And here, what we're looking at the statistics, okay, minus the parameter, right, minus the parameter divided by the standard deviation, right, the standard deviation of the sampling distribution, right? So if you look at this question, and it is a proportion question, right? P proportion. Statistics comes from here. Nope. Statistics comes from the sample, right? Statistics come from the sample, and the sample is here. So you have 200 out of 500. Actually, we haven't even read the question. So a campaign manager for a political candidate released a series of advertisements criticizing the opposing candidate in an upcoming election. The opposing candidate previously had the support of 45% of the voters. So the manager wants to test if the null hypothesis population proportion is equals to 0.45 versus right after the advertisement did the voting popularity went down? Did it decrease less than 0.45? Where P is the proportion of voters that support the opposing candidate. After running the advertisements, the campaign manager obtained a random sample of 500 voters and found that 200 of those sampled supported the opposing candidate. So this is what it looks like. So you have the p hat minus the p divided by standard deviation is this. P times 1 minus p divided by n. So this is the formula that you need to know for the z statistics. And in this case, the p hat we know to be 200 out of 500. So 200 out of 500, and that is 0.4, right? 200, let's see, 200 divided by 500, yeah, it's 0.4, okay? And your P is 0.45, right? Your P is 0.45 right here. So how do we find the Z statistics? Now we put everything together. So 0.4, right? Because P hat is 0.4 right here, minus 0.45. And we do not need to work it out because look at the options. It doesn't need us to work it out. It just want us to put things together to see if it works. 0.45 times 1 minus 0.45, which is 0.55, divided by, and the sample size here is 500, right? It's 500. So any of those options look like this. Let's see. So you have 0.45 minus 0.4 divided by 0.45. That doesn't work. And so, mm, yeah, this one, right? That's the population. What is it? So 0.45 is your population parameter. So we are doing zero point 0.4 minus 0.45 divided by square root of 0.45 times 0.55 divided. Yeah, isn't this the one that I wrote earlier? Okay, so another question here. Um, According to a very large poll, right, in 2015, about 90% of the homes in California had access to the internet. Market researchers want to test if that proportion is now higher. So they take a random sample of 100 homes in California and find that 96 of them have access to the internet. The researchers will test H naught, right? H naught, null hypothesis is population proportion, P equals to zero point 0.9, right? Came from here, versus the alternate hypothesis that you think that they have, what is it? It's now higher, right? You're expecting, you want to test if the proportion is now higher. So it's greater than 0.9, where P is the proportion of homes in California that have access to the internet. Assuming that the conditions for inference have been met, right? The three conditions, the random, the normal, and the independence conditions have been met. Calculate the test statistics for their significance test. So this is the Z statistics. So we talked about it in a previous example. The Z statistics as a formula. Z statistics is P hat minus P divided by square root of P times 1 minus P divided by N. So you can put everything together, right, in a calculator, and that should work out. So P hat, and we were told 96 out of 100 will be 0.96 minus P is 0.9 divided by 0.9 times 1 minus 0.9 is 0.1 divided by N, which is 100. So if you work this out, you should be able to get your get the Z statistics. So if you do this by hand, now there is a quicker way. What is a quick way is to use the calculator. So please follow, right? So you go to stat, and then you go over to test. Then I want you to go to one proportion Z test, number 5. Now, why 1? Because we are dealing with only one sample, right? One proportion, because we're dealing with proportion, Z test. And it will ask you, so P naught is your claim. What is your original population proportion? Here, our population proportion is 0.9. And then X is the number of success, which we know here to be 96. And what was the sample size? Sample size is 100 right here. Now, then we need to be careful. What is my alternate hypothesis? So here, my alternate hypothesis is greater than. See, this is this symbol, greater than. Then we need to pick the greater than sign. Okay? We need to pick greater than sign, and then just go to calculate. Voila! Do you see my Z statistics right here? My Z statistics is 2. So just put a 2 here, and that works. Okay, so let's do another one. Let's see if the next one. Oh, the next one is not as kind. The next one is you just have to put the values in together, right? The next one is you got to find the Z statistics equals to P hat minus P divided by square root of P times 1 minus P divided by N. So you put everything in here, right, and see if it works out. So what's my business knows that 30% of its customers are less than 25 years old. The business wants to increase this percentage, so they create a marketing campaign that targets this age group. After the campaign, they take a random sample of 50 customers, so the N is 50, to test for the null hypothesis. Population proportion equals to zero point 0.3, right? Came from here, 30%. And the alternate is more than 0.3 because we want to know the business wants to increase this percentage. They want to know if that was done after the campaign, where P is the proportion of this business customers who are less than 25 years old after the marketing campaign. The sample result shows 18 customers who are less than 25, 18 out of 50. So 18 out of 50, 18 divided by 50. So your sample proportion is 0.36, right? So here your sample proportion is 0.36 minus P is 0.30 divided by square root of 0.30 times 1 minus 0.3 is 0.70, zero point 0.7, sorry, zero point 0.7 divided by what is the sample size, 50. Okay, so which one would work? We know it's going to be 0.36 minus 0.3. So 0.36 minus 0.3, okay, divided by square root of 0.3 times, yep, right here. This one looks correct. So if you have any questions, just let me know.